Have you ever feel such kind of mysterious force whenever you move from north to south pole or south to north pole over the surface of the earth? Now, there is a mysterious concept behind such kind of forces, and this is not a micro force. This is a major force experienced by a big size of type of bodies. Like I can think of right away the water ships. What is the mysterious concept behind such kind of forces, which is simply known as Coriolis Force. Hello there, this is Vivek Chauhan again presenting a new video on our lecture series, which is simply named as General Theory of Relativity, and this is a part second of such kind of series. What we have done, one part of the same kind of series. So in this video we will take the look on such kind of new terms which I have given to you in the last video. So up till now, in the first video, we have completed the general concept about frame of references, and also we have completed one kind of frame of reference which is simply pervade as named as inertial frame of reference. Okay, and in order to understand by frame of reference as inertial frame of reference, I have given to you the example of a moving train, and the velocity of the moving train was observed by three kinds of person, and one was moving with such with the same speed as that of the train is moving, and another person was having such a kind of speed with the same speed as the train is moving in the opposite direction, but the last one person, the third person, was having speed as 0. That was the rest in the which related to the train which was moving. I think that was the velocity what I have given to you, 40 km per hour, if I am right to think about the velocity of the train. I think that is the right. Okay, now in this video we will look at the second kind of frame of reference, which is simply known as non-inertial frame of reference. Okay, so in the last video we have completed first kind of frame of reference, inertial frame of reference, which with a lot of number of example what I have given to you in the first kind of frame of reference. Okay, so let's move towards the non-inertial kinds of frame of reference. Okay, so let me write here the name of the topic, that is a non-inertial frame of reference. Okay, so our topic is this. What about the first kind of frame of reference what we have discussed in the last video? The inertial kind of frame of reference are such kind of frame of reference in which there is no acceleration of the body. If you observe the speed or acceleration or the all other physical quantities of a body is staying in one frame of reference, and there is no variation in the velocity and acceleration of that object, then such kind of frame of reference is simply leaded to the one kind of frame of reference, that was the inertial frame of reference. In other words, inertial frame of reference is such kind of frame of reference related to which an accelerating body is unaccelerated. Okay, let me sum this. Okay, just think about this example of frame of reference. I have given to you one kind of frame of reference which is simply the inertial frame of reference. Okay, now also consider a body which is staying in this frame of reference, and body is this is the body. Now let us assume that this complete frame is moving with a constant velocity v equals to 50 km per hour. Okay, as I have told you, body is staying is at the rest in this kind of frame of reference, so body will also be move with the same kind of speed what is that of the frame of reference. So what about the acceleration of the frame of reference and the acceleration of this body? 0, because there is no change in the velocity of the frame of reference, and after all there is no change in the velocity of the body, because it is staying in the frame of reference. And also one important thing is there, the relative velocity of the body with respect to this kind of frame of reference is 0. So such kind of frame of reference is simply known as inertial frame of reference, related to which an unaccelerated body, this is not accelerating, this is not moving with such some kind of velocity, no. So frame of reference, such kind of frame of reference in which, or related to which an unaccelerated body is unaccelerating, is simply known as inertial frame of reference. Okay, now let us move towards the non-inertial frame of reference. I can think right away an example of in order to understand the non-inertial frame of reference of a body. Let us move in this way. Okay, just consider an inertial frame of reference. Inertial frame of reference, this is inertial frame of reference. Okay, now also consider a body which is at rest in this kind of frame of reference. Now consider another kind of frame of reference. Let's say this is S and this is S dash, which is accelerating with some kind of acceleration with respect to this frame. Okay, so let us say this S dash frame of reference is moving with acceleration A. Okay, now the position of the S dash, is timely changing with respect to S. Okay, now if a person is staying in S dash, let's say there is a person or observer in S dash, and this person is observing the acceleration, or it is keeping his eye on the body which is staying in the S. Then what about the acceleration of the body observing by this person? This is just simple task. This frame of reference is at rest, so its acceleration is 0. Okay, and another kind of frame of reference, what I have named as S dash, is accelerating with acceleration A, and a person is staying in S dash, this one. Now if I ask to this person what is about the acceleration of this body which is staying in S, he will observe, he will appear, this body is moving back. This body is moving back with same kind of acceleration that is having by this person A, but in opposite direction. Okay, this person is moving in this direction. Let's say this is a X positive direction, because according to S dash, because S dash is also moving with acceleration A, that's why a person will also accelerate with the acceleration A. Now it is keeping his eye on this body. Then body will seemed by this person moving back with the same kind of acceleration having by this person. So the acceleration of body is staying in S observed by this person will be minus A. Okay, because I have taken negative here, and the reason is that because this body will appear moving in opposite direction, so opposite I have taken negative as there. Okay, now I am standing here, my velocity is 0, I am staying here, I am at rest. Okay, now if another person asks me to what about the velocity of this body according to me, then I will say the velocity of this body is 0 as well as acceleration is 0, because I am at rest, body is at rest, relative velocity of the body and me is 0, so I will observe the velocity of this body as 0. What there is a variation of the observance of the velocity given by me and given by this person. I am saying the acceleration of the body is 0, and this person is saying the acceleration of this body is minus A naught, minus A. Okay, so this person which is staying in S dash observing the acceleration of this body as minus a, and if you briefly see on the S dash as well as the person, then you will observe that what. Okay, let me sum up here. I can take example of real life phenomena, and in order to understand this kind of phenomena also. Whenever you move with your bike or any kind of vehicle, and you are looking at the pavement of the road, on the concrete laying on the pavement of the road, and you are moving with that of vehicle, you are staying in the vehicle, okay, then you will observe that whenever you look down from that moving vehicle in which you are sitting, then you will observe pavements, concrete are moving back. You are moving in this direction, and you will look at the pavement concrete, that concrete or any particle at road, that will be appear to you moving back with the same kind of acceleration what you have, but in opposite direction. You are moving in this way with some kind of acceleration, let's say a. Now that particle which is laying on the pavement of the road, then that will be appear to you moving back with the same kind of acceleration what you have in this direction. Okay, now overall there is no motion of that concrete laying on the road, but you are experiencing an acceleration having by that particle. So now the vehicle in which you are sitting, in which you are taking the journey, that is simply known as non-inertial frame of reference. Okay, in the same way, if this is a vehicle and that is that person which is observing the particle laying on the pavement on the road which is at rest, then he will observe that this particle moving the back direction with the same kind of acceleration what he has, but in opposite direction. So in that particular case, this S dash will be known as non-inertial frame of reference. Okay, now it can also sum up as that a frame of reference, relative to which an unaccelerated body is accelerating or accelerated. Now just look at these two words. I have written here a frame of reference relative to which an unaccelerated body is accelerated. So here that kind of frame of reference what I have given to in the context is a frame of reference, this one I am talking about, this one, a frame of reference, this one frame of reference, relative to which an unaccelerated body, this is an unaccelerated body, the acceleration of this body is 0, so this is unaccelerated body. Unaccelerated body is accelerated, yes, this body is accelerated according to a person which is here, who is here. Okay, so this kind of frame of reference will be known as non-inertial frame of reference. So this is the definition, you can go through this. So whenever you come across such kind of frame of reference in your daily life phenomena, you can categorize that in the second kind of frame of reference, non-inertial frame of reference. So I think this is the enough and a brief idea about the non-inertial frame of reference. Also there is acceleration which is simply leads to the body in the non-inertial frame of reference. So whenever there is acceleration, that causes the force. Okay, so the such kind of force which are due to the non-inertial frame of reference are simply known as fictitious force or pseudo force or accelerated force. Okay, so now let's talk about a little about fictitious force also here. Fictitious or pseudo, here P is silent, just remember this thing, force. Okay, now again I am taking the example of same kind of phenomena. Let's say again I am taking the example of a concrete laying on the pavement of the road, and you are moving in the vehicle and observing the velocity of that particle. Okay, so this is the rod on which you are moving. This is your vehicle and you are here and you are looking at a particle which is here, and you are moving with the acceleration a naught. Okay, you are moving with the acceleration a naught with your vehicle, and you are looking at a particle, this one, for a particular instant at which you had just looked at this particle along with your motion, along with your vehicle which is moving this direction. Then this particle will appear to you moving in back direction opposite to your direction of motion. Then there is an acceleration which will be experienced by you in opposite direction, and that will be experienced by you in such a way that this kind of particle having the same acceleration a naught but in the opposite direction. Okay, then the acceleration of particle experiencing by let's say appearing by experiencing by you, I am taking it as experiencing by you. Experiencing by you will be minus a naught. Okay, so whenever there is acceleration, that leads to a force. So the force which causing the acceleration a naught on this particle, which is not existed, okay, that will be F equals minus m a naught, where m is nothing but the mass of this particle what you are looking at. Okay, so F equals to minus ma is that kind of force which is leading to this particle causing the acceleration a naught experiencing by you. In the simple words, you will experience that, you will think about that this particle having an acceleration a naught, and whenever there is acceleration there is a force. So you will look at this particle, you will feel that this particle is having this kind of force leading to acceleration a naught, but in the opposite direction of the direction of your motion. So this kind of force which is actually not existing, there is no force acting on this particle actually, because this is staying, this is at rest, it is at rest on the pavement of the road, but it is experiencing by you because you are moving in the opposite direction of this particle which is at rest. Okay, so such kind of forces are simply known as fictitious force or pseudo force. Okay, I am again repeating that this is nothing, this is not existing in the nature, this is only due to your motion. So such kind of fictitious force which has no existence in the universe, but it appears due to only your motion, is simply known as fictitious force. Okay, so I think this is enough about general idea of fictitious force. Okay, now let us take a just complex example of this particle also. Now look at the another condition. In that condition, let's say this particle is also moving in this direction with acceleration a. Okay, I am repeating. Let us take an example that this particle is moving with acceleration a. Okay, now you are observing the same. You are observing of this particle sitting on your seat in this vehicle. Okay, then the actual acceleration of this particle is a, and the acceleration experiencing by you on this particle, that is minus a naught. The complete acceleration will be a minus a naught. Okay, so complete acceleration which is experiencing by you for this particle is a minus a naught. negative here due to the opposite direction of the motion. Okay, then if I multiply with the mass on this total acceleration, then I will get the total force on this particle experiencing by you for this particle. Okay, now just rewrite the terms ma minus ma naught. What about ma? Ma is nothing but the force due to the acceleration a on the particle. So let's say this is the fi or fa, actual force, okay, and minus ma naught, and this is the ft, f total. So f total is equals to, this is f total, f total given by this person for this particle. Okay, so f total experiencing by this particle for the experiencing by that person for this particle is f total. He will say the total force on this particle is fa minus ma naught. So he will experience two kinds of forces on this particle. If this particle is in motion with acceleration a, fa and minus ma naught. And if you observe this particle at rest, if you are standing here out from your vehicle and you are at rest, you are taking the look at this particle, you will say only and only one force is acting on this particle, which is only ma, fa, not ma naught. So this term will vanish when you will at rest. So this term lives as long as you are in motion related to this particle. So this kind of force is known as simply Fichtes force, fa minus fc, and fc is nothing but fa minus f total. You can also go through this formula here. Okay, so I think this is a brief or longer idea about the Fichtes force. I can think right over it. Okay, now let's talk about a very interesting topic which is simply pervade in the world by naming Coriolis Force. Okay, so I am taking here Coriolis Force. So what about the Coriolis Force is? Let us assume there is the two non-inertial frame of references. Okay, so I am taking here one kind of frame of reference S. This is a S frame of reference. Let's say this is S here, and another frame of reference having the same origin O, but which is moving with moving in rotation kind of motion with respect to S. Okay, let's say this is here at a point. Let's say it is here. This is another kind of frame of reference as this. So this one is one kind of frame of reference. Let's see, it is here, and this is another kind of frame of reference. You can look at here. Now this is a perfect diagram. So this is a one kind of frame of reference, you can check here, and this is the another kind of frame of reference, you can check here also. This one is, okay, this one is, and this one is another kind of frame of reference, you can look at here. Now let's say as this is moving in rotation kind of motion with respect to S with a constant angular velocity omega. So this is moving in this way with a constant angular velocity omega. Now there is a particle here whose position vector from the origin is r, vector r. Okay. Now what about the coordinates of this particle P experiencing by a person in S dash as well as in S individually? Now I will look at the same kind of, okay, let me take the brief idea of this kind of phenomena what I will take to you. This is one kind of frame of reference S. This is the another kind of frame of reference S dash. S dash frame of reference is moving in rotation kind of motion or is rotating with a constant angular velocity omega with respect to S. Now there is a particle P or phenomenon or an event P here whose position vector is R from the origin O. You can also look at here the origin of both kinds of frame of reference are coinciding O. Okay. Now also let's say this is the x-axis, this is y-axis and this is z-axis for S dash frame of reference. So in frame of reference S, these are the x-axis, y-axis and z-axis in kinds of axis, and this is the x dash this one is let's say x dash axis, this is y dash axis and this is z dash axis for second or S dash kind of frame of reference, x dash axis, y dash axis and z dash axis. Now you can resolute the position vector R for this particle for the both kinds of frame of reference. Okay, so let's say the position vector R observing by an observer from S frame of reference at origin O. Let's say there is a observer at point O and it is looking at point P from S frame of reference. Okay, so he will look at xi plus yj plus zk. He will give you these kinds of position vector for this particle P vector R, where x, y and z are the coordinate of particle P according to S frame of reference by observer O, and vector I cap, vector j cap and vector k cap are simply the unit vectors along x axis, y axis and z axis respectively. For the same kind of position vector observing by another observer again at origin but in the another kind of frame of reference, I am again saying another observer is standing in S dash kind of frame of reference but at origin. Also first kind of observer was also here but that was in S frame, and now the second one observer in the S dash frame of reference. Okay, so he will look at the coordinate of the same particle P or event as x dash I dash plus y dash j dash plus z dash and k dash. So this is for S dash and this is for S. Okay, now as I have told you, S dash is moving, is rotating with respect to S. If the observer in S dash is looking at point P, then he will say the P point is moving back because it is moving this direction. P will appear to that by that person rotating in the opposite direction. Okay, so he will say that there is a velocity having by this particle but in the opposite direction. So the velocity of the particle P experiencing by observer in S dash will be, what will be that? That will be d dash r over dt. I am talking about S dash frame reference context. Okay, so this is d dash r over dt. That will equals to what? Dx over dt vector I, differentiate this equation with respect to time. So the rate of change of r, x, y, z with respect to time will be like that. Okay, so that will be d by over dt kind of j, and plus this will be dz over dt kind of k. This is a simple equation. You can go through this. Let's say this is equation number 1 here. Okay, let's say these are the two equations, one, and this is the second equation, and this is the one equation A, and this is the second equation B, and combinedly I have given them as 1. Okay, now again, so this is the time derivative of position vector P observed by an observer placed in S dash, this one. Okay, now what kind of the same kind what kind of the velocity of the particle P observing by another observer in S frame of reference? He will observe that. What he will say, I am talking about the S frame reference, so I am not taking the dash here. So this is what about the S. So this is dr over dt equal. Now he will say the position of the particle P is changing. Okay, so position of the particle P is changing. According to that, sorry, this one is dx. Okay, this one is correct. So this, he will say dx over dt and dy over dt j plus dz over dt k. Also let's okay, this one is for S dash frame reference, so this will be dx dash, okay, and I dash, dy dash, dz dash, dj dash, dz dash, dk dash. Okay, and this is for about the S frame reference. So dx over dt kinds of vector I plus dy over dt times of vector j plus dz over dt times of vector k, and this for all again dash. Now relative to the same observer which is placing in S, the unit vectors of S dash are also changing. Okay, I am just removing or rubbing this kind of frame of reference for the convenient. Let's say this one is also here. Now just look at this frame of reference. This is the S dash frame of reference and particle P is here. If an observer is observing the position vector, the change in the position vector of P in this frame of reference, he will say the position vector time derivative will be like this, because x position is also changing for P, y position of particle P is also changing, z position of particle P will also change, because x, y and z are also moving with this S dash frame of reference with respect to P. So x dash, y dash, z dash, all the three coordinates will be changed. Now same kind of event if observed by an observer placed in S frame. Okay, he will say relative to which S dash, he will say x dash, y dash and z dash, x dash, y dash and z dash are changing, as well as their unit vectors are also changing. This is said by an observer which is observing in S frame. So according to him, I dash is also changing. So I dash is also changing, z dash is also changing, k dash is also changing. Then the derivative of I dash times of dx dash over dt will be like that. So differentiate equation 1b according to that person. So dx dash over dt is here. Now differentiation of I dash will be d I dash over dt, x dash is same, plus this will be dj dash over dt and y dash is same, plus dk cap dash divided by dt kinds of z dash. This is the observation of time derivative of position vector of P observed by an observer S O in S frame of reference. This one is the equation. Okay, now you have remembered one formula that V equals R omega or omega R in vector form. This one is like that. V is the linear velocity, omega is the angular velocity, I is the position vector. So here I dash is changing, and I is nothing but the displacement, unit displacement in x direction. So this one is also a displacement with respect to time, is simply leads to the velocity. So straight, because this is along to the x axis, this is a straight displacement or linear displacement with respect to time. So unit linear displacement with respect to time will give you the unit linear velocity. So that will be di dash over dt. That is the velocity along unit vector I dash of a particle, and that will equals to omega cross and multiply by I dash. According to this formula, let here I can write this as dr over dt. Okay, so dr over dt is nothing but omega into r. This is a v, b equals to omega r, and b is nothing but the time derivative of position vector with respect to time. Okay, so in terms of I dash, that this formula will lead to di dash over dt equals to omega times of I dash. Okay, so again also dj dash over dt will be equals to omega cross vector j dash. Also dk dash over dt will equals to omega cross k cap dash. Okay, so these three formulae can be used here. So I am using the same. This is a dr over dt equal, this is nothing but this complete factor from equation 2 can be replaced by dr dash over dt. Look at here, dx dash over dt I dash plus dy dash over dt j dash plus dz over dt k dash. This complete factor is also appeared here, and this is nothing but equals to dr dash over dt. This one is here, plus di dash over dt is equals to the omega cross I dash. So this one is omega cross I dash, okay, this one is here, and multiply with the x dash, okay, plus dj dash over dt equals to omega cross j dash. This is omega cross j dash multiplied with the by dash. This is scalar multiply, and plus dk dash over dt is nothing but equals to omega cross k cap. So this is omega cross k cap dash, and multiply with the z dash. Okay, now you can easily see that omega is here, omega is here, omega is here, omega is appearing, all three terms can be taken out from the bracket as common. So this equation also have the phase like omega is common, vector omega cross is common, and x dash will be operated on I dash, vector I dash or k I dash k. So this is x dash times of I dash plus y dash times of j dash plus z dash times of k dash. Okay, I have done nothing. I have just taken common omega cross. So omega cross is just common. X dash I dash plus y dash j dash plus z dash k dash is here. Again, you can complete this equation from first V equation. This is x dash I dash plus y dash j dash plus z dash k dash equals to the r, again r. So this equation can also be written as d dash r over dt plus omega cross nothing but vector r. This is going to equal dr over dt. So this is what we have up till now. Okay, let me rub these equation. So up till now we have reached at this position, and this is okay, this also is. So what we have up till now, we have dr over dt equals d dash r over dt plus omega cross vector r. Okay, let us remove it also. Now this is a mathematical expression, so do not bother with this. This is very important Coriolis force concept. After completing this mathematical interpretation, we will look at the physical significance of Coriolis force. So do not bother, do not take stress, do not take as disappointment in your mind, just to look at the procedure of the mathematical formulation of the Coriolis force. Okay, so just be with me, trust me, this is very simple concept. It is not the mysterious concept what we usually say there. So this is the simple kind of article. As you are the physics student, so you should not fed up with such kind of mathematical formulation. Okay, so just rewrite these terms or in this way. If I made this equation in terms of operators, then the form of this equation will be d of dt equals to d dash over dt plus omega cross. I have done nothing, I have just removed r from the equation 3, and it also can be said that this is a this is a form in which operators are there. Okay, so this one is the operator form in forms of operators or derivatives. This one is here. Also we have the d. What about the d square r over dt square? This is the double derivative of the position vector. And why I am taking interest in the double derivative of the position vector? Because I have to generate formula for the Coriolis force, and Coriolis force nothing but mass into acceleration. So what about the acceleration of the particle? So the double derivative of the position vector is simply known as the acceleration. So this is the acceleration of the particle which leads to the Coriolis force, ma. This is a a. Okay, so d square r over dt square is nothing but the derivative of dr over dt, time derivative of dr over dt, simple. Okay, now you can replace d of dt from here. You can put d of dt as this one. Okay, also dr of dt is nothing but from this equation. So just rewrite equation 3 and equation 4 and equation 5. So put equation 3 and 4 in equation 5. Okay, so this equation will be d square r over dt square equal d of dt is nothing but d dash over dt plus omega cross. This is the value of d of dt, right? What about the dr over dt? Dr over dt from equation number 3 is d dash r over dt plus vector omega cross vector r, right? This is the final term what we have to solve lastly. Okay, so I can remove these terms here. So just rewrite this equation again. Now I am multiplying this factor with this factor. Okay, so d dash over dt will be operated on d dash r over dt. Okay, so that will be, this is d square r over dt square. Okay, d dash over dt will be operated as d dash r over dt. So you will have to differentiate this equation again with respect to t. Okay, so the equation, the form of this factor will be d dash square r over dt square, correct? Because d dash and d dash becomes d dash square and dt and dt will become dt square. Okay, now d dash over dt will be operated as vector omega cross vector r also. So that will be plus d dash over dt will be operated at omega. So that will be d dash omega over dt. Okay, cross. Okay, first this is a multiplication, so that will be the derivative of the two functions which are in the product. So this is, let's say this is fx, this is ux. So differentiation of fx kinds of ux will be differentiation of fx and ux same. plus differentiation of ux and fx same. Okay, so this is d dash omega over dt, okay, and cross what, r is same, now plus d dash over dt will be operated on r and omega will be same. So omega, let me write here omega as here, so this will be dr over dt as here. Okay, so this is done. Now the turn is for vector omega. So vector omega will be in the form of cross multiply of dr dash over dt here. Okay, so that will be plus omega cross d dash r over dt for this, and plus vector omega cross vector omega cross r here. Okay, so this is what we have up till now. So just rewrite this equation again. The kind of this equation will be lead to as, you can look at here, these are the two terms what we have same, so they will become 2 times of vector omega cross vector d dash r over dt, right? Also we have here, this one is d dash omega over dt kinds of vector r, okay, and plus we have written this one and this one here and this one here, so the rest term is this one, omega dash cross vector omega cross vector r dash. So this is what we have, the final term. Okay, so let me rub this also. This complete factor is going to equal d square r over dt square. Now let us sum up this formula, what have we done up till now. Just look at this factor, one by one we will check each one factor what you are looking on the board with this black dot, okay, black dot marker. This is d square r over dt square, this one. R is the position vector or simple displacement of particle p. This is a double derivative of time with respect to r, double derivative of r with respect to time. So if you differentiate displacement by double, you will get the acceleration. Okay, so this kind of factor is showing the acceleration of what, particle p, because r is the position vector of particle p in s frame, because there is no s here. So this is the acceleration of particle p observed in s frame, acceleration of p in s frame. Okay, d dash square r over dt square, this is nothing but same acceleration of particle p but in s dash frame, because here dash is taken. Okay, so and what is about this factor? This factor, okay, let me write down this factor. This is a special term what we have. This is the 2 times of vector omega cross d dash r over dt. This is the one term what we have. This is the, okay, this is the one term here, this is the second term here, this is the third term here, this is the fourth term, and this is the fifth term. So this one is first, this one is second term, and this one is third term what we have up till now, and this is the fourth term what we will write here, d dash omega over dt times of vector r. Okay, also we have fifth term is vector omega cross vector r. Just let us take look one by one on these all 5 factors. I have told you what are the significance of these 2 factors. Now just look at on this factor. Just talk about this factor. This factor is simply 2 times of angular velocity multiplied with the linear velocity, because this is the first derivative, first time of derivative of position vector, but in s dash, because this is the dash derivative of r with respect to time. So this is the velocity of the particle p observed by an observer in frame of reference as dash, because dash is here. So this one is nothing but 2 times of angular velocity and multiply by what? Linear velocity. This is, I am taking it as v dash. Okay, such kind of this kind of factor is simply known as Pseudo Force. What is the physical significance of this factor? We will discuss this later. Okay, so this is simply known as Pseudo Force here. Sorry, Pseudo acceleration. Sorry, Pseudo acceleration. Okay, because all dimensionally this equation is correct. This is acceleration, and there is a addition of the same kind of physical quantity in one type of formula. So this is acceleration equals to acceleration plus acceleration plus acceleration plus acceleration. So okay, now let us look at this formula. This formula is just nothing but this is a mathematical quantity. We will look at there later. Just look at the fifth kind of factor. This is the omega and r. If you write this equation in scalar form, you will get omega and omega square kinds of r. So omega square kinds of r, nothing but just v. So v equals to r, acceleration, simple a equals to r omega square. You can you have heard about this formula in your 11th class, very first time. Okay, so acceleration is nothing but r times of omega square. So this is omega square r. This is simple acceleration, angular acceleration also here. Now what I want to talk to you with, this is the acceleration of the particle, actual acceleration of the particle. This is the acceleration of the particle in s dash frame. So actual acceleration of the particle is equals to the acceleration of the same particle observed from s dash frame, which was moving with a constant angular velocity with respect to s. Okay, plus some kind of this acceleration. This is simply known as Pseudo. This term is simply named as Pseudo acceleration. This is nothing but the constant quantity, because omega was constant, s dash was rotating with the constant angular velocity. I have told you very first that s dash is moving with a constant angular velocity omega. So this omega is a constant, time constant. So the derivative of omega with respect to time will be 0. So this factor vanishes if s dash rotates with constant angular velocity. Okay, so this factor exists as long as there is acceleration in the rotation motion. Okay, so omega is constant, so this factor is 0 for our consideration what we are discussing here. And this is nothing but the angular acceleration of the particle p observed from the frame s, because there is no dash here. So the actual acceleration this is the actual acceleration of the particle equals to what? Acceleration observed from s dash, this is 1, and plus Pseudo acceleration or Coriolis acceleration also here, Coriolis acceleration, and plus this is a time constant quantity. So I am taking it as directly simple d dash omega over dt cross vector r. This is a time constant for constant omega. and this is nothing but the angular acceleration. Angular acceleration observed from S frame. So this is the actual acceleration of the particle P observed from the S frame. Okay, now just take only this term in order to understand the Coriolis acceleration and then Coriolis force. So the Coriolis acceleration is this one. Coriolis acceleration. This is AC. Coriolis acceleration is nothing but 2 times of omega cross vector d dash r over dt. Sorry, this one is vector also here. If I multiply on the both side by m, then I will get the force which leads to the acceleration. Here m is also, which is simply known as Coriolis force, because mass times of acceleration gives you force. So this is the Coriolis force, or Fc. Take a new name to this force, Coriolis force Fc. So Coriolis force is just nothing but 2m times of vector omega cross vector d dash r over dt here. In order to rearrange or convert this formula in scalar form, you can go through like that. Fc will be equals to 2m omega, and this is nothing but the linear velocity observed from the S dash frame of reference. So this is nothing but v dash. Okay, and sine theta n cap, where theta is nothing but the angle between the linear velocity to the angular velocity of the particle. Okay, so this is the scalar form. You can check here. Now let us break out this phenomena in 2 conditions. If theta equals to 0 and another is theta equals to let's say 90 degree, because I am taking only 2 conditions for the minimum value of sine and the maximum value of sine. Okay, you can check here, there is a cross product between omega and v here. So omega and v, there is a cross product between omega and v. So these are the quantities which are perpendicular, the resultant omega cross b will give you a vector quantity which is known as Ficht's force. If I talk about the direction of Coriolis force, then that will be determined by the screw rule. So if this is omega, this is vector b, and this is the angle between them, then according to screw rule, the direction of the Coriolis force will be like this. Okay, so it will always be perpendicular. It will always be perpendicular to the cross product of omega and b. Okay, so if this one vector is showing the vector omega, this one is showing the vector b dash, then this red color pen will show the direction of the what? Coriolis force. Okay, also you can check here what is the maximum value of the Coriolis force and what is the minimum value of the Coriolis force. So if you put 0 in this formula, you will get sine 0 and complete term will be 0. So Fc will be 0. And if you take the 90, if you put the theta equals to a 90, you will get sine 91, and this will be the maximum value of the Fc, and that will equals to the Fc equals to 2m omega v dash. Okay, now what is the physical significance of these 2 formulas? You can check here, if the particle is moving with velocity b dash according to frame S dash, which is moving with a constant angular velocity omega, then the particle will experience a Coriolis force, which will be always tend to do that particle in the direction of omega and b, in the perpendicular direction of omega and b, because whenever there is a 90-degree angle between omega and b, the Coriolis force is maximum. So the direction of the Coriolis force will be always in such a way that will be perpendicular by both the quantities omega and v dash. V dash nothing but the velocity of the particle p experiencing by an observer placing in as dash frame of reference. So okay, now I am taking an example of a person moving in from, let's say, north to south geographical poles of the earth. So there is a person here basically moving in this direction, and you know very well earth is moving from west to east direction as its spin motion, rotational motion about its axis. So this is a person whose velocity is in this direction, north to south, okay, and this complete frame of reference is moving perpendicularly because north to south direction is of velocity of the person and west to east direction is of the frame of reference, which is simple, the earth. Earth is non-universal frame of reference, okay, what I have told you. So there is a perpendicular relation between the v dash and omega. Omega is in this direction, so this is a 90-degree angle. So Coriolis force acting on this particle will be given by 2m omega and b dash. Okay, so Coriolis force experiencing by this particle will be this, and that will be in the direction what? In the perpendicular direction of the omega and b. So this one is v direction and this one is what? Omega direction. This one is v direction, this one is omega direction. Okay, so Coriolis force on the particle will be, so these are the two forces, sorry, two vectors, v, and marker is showing the direction of omega cross. So the Coriolis force on the body will be in the way of my thumb. Okay, so this is the direction of the Coriolis force on the particle if it allows to move in this direction. Okay, so these all we have discussed is about to the mathematical interpretation and some kind of physical significance of Coriolis force, what you can look at here. The derivation of Coriolis force formula or Coriolis acceleration generally asked in the examinations, most important kind of examinations, even like UPSC examination. If you have taken the physics as optional in your UPSC or civil service examination, whatever it is, the state civil examination or state-wise civil examination or union kind of civil examination like IAS, IPS or whatever, then this kind of article is mostly appeared in the examination. Also this kind of mathematical interpretation of the Coriolis force and acceleration is also appeared in the academic kind of examination like BSc and BTech, technology kind of courses like BTech. Okay, so I think this is enough about the Coriolis force mathematical interpretation and the physical significance. This one is also a part of our lecture series, which is the general theory of relativity, and this one is related to the non-universal frame of reference, what you can see here. Okay, in the next video we will take a look on the invariance by the Galilean transformation, invariance in the general rules like Newton's law and some kind of phenomena. Mean what is the invariance in the general fundamental laws according to relativity. So we will apply the Galilean transformation on them. If there is no change in the structure and the concept of the formula, then that will be said as there is no invariance or the formula is invariantly correct. Okay, so I think this is enough to stop this video. Thanks for watching this video.